Welcome. Hi, this is Bill Curtis. I'm the Executive Director of the Consortium for IT Software Quality, and we welcome you this morning to our webinar series. Today we're fortunate to have Dr. Carol Woody from the Software Engineering Institute talk to us on applying software quality models to software security. Dr. Woody is the Technical Manager of the Cybersecurity Engineering Team at the Computer Emergency Response Team at the Software Engineering Institute at Carnegie Mellon. Dr. Woody is going to talk about the research they're doing at SEI on tying and relating software quality and software security and how they're intricately allied at both the code and the system level. Dr. Woody, over to you.
Thank you very much, Bill. It's my pleasure to share with the listeners recent research that we have just completed in looking into the relationship between quality and security. For those of you who may not be familiar with the Software Engineering Institute, we are a fully funded research center for the Department of Defense underneath the umbrella of Carnegie Mellon University. Next slide, please. I do want to point out that all of this information is prepared for public release so that you may use it and share it as you wish, and we have the opportunity to share it with you. Next slide. To give some context on the research, the team I lead, Cybersecurity Engineering, has been focused on the cybersecurity challenges for software development in acquisition across the life cycle. We have a range of areas we have been exploring, and the website there will provide you further details as well as a link to the detailed report about the research that I'm presenting today. Next slide. This particular presentation is focused on the area of security and software assurance measurement and analysis that we consider to be extremely critical within the portfolio and have been diligently working to expand the capabilities in that area. Next slide. Our perspective is that cybersecurity is a life cycle issue, and it needs to be considered at every step within the life cycle. We identified that quality has a similar approach. Therefore, we looked for ways to identify how these two are related and the potential for synergies. Next slide, please. Our quest led us into conversations with the Team Software Process Group, which is another research area within SEI that is focused specifically on quality. This particular group has been collecting data on over 100 projects for many years across the full life cycle for each one of these projects. And within that data, we identified 5 specific projects that delivered very low or in many cases 0 defects for safety and critical and security results. This was in the first full year of actual implementation. If quality alone had been the answer, then we would have expected that all of these 100-some projects would have produced these results, but that was not the case. So we felt that this research was worth digging into to figure out what was going on with these unique 5. Now, we included safety critical as well as security because we have seen that the results are comparable, and that also gave us a larger set to look into. Next slide, please. The discussions with our quality expert colleagues led us to recognize that there's some major semantic differences in what quality analyzes versus what security looks at. Quality primarily focuses on the non-fulfillment of requirements, and they look very extensively into accidental conditions, how some functionality would fail to perform. Security, on the other hand, looks very closely at the operational aspects and is concerned about the attacker and their involvement. So in cases of what we're looking at then, we know that some defects would be considered vulnerabilities, but not all, because it failed to perform functionally what you were going to expect it to do, that may or may not be a defect. And in their cases, they also include documentation variances, which we definitely would not have considered on the security side. All vulnerabilities should be considered defects, but they wouldn't be discovered primarily, it looks like, because of poor or incomplete requirements. Next slide. Further research identified for us a more specific relationship. We were finding that about 1 to 5% of the reported defects should be considered vulnerabilities. So this could be used as a useful rule of thumb. If you're going through a process tracking defects, then you've got some effective number that you might want to consider as vulnerabilities. That's the level of risk that you would be adopting when you implemented the system at that point in time. Next slide, please. The specific data we found from these 5 projects came from 3 different organizations, and we felt that it was sufficiently interesting enough to do a deep dive into what they were doing. We had the contacts to do that and pursued them on a one-on-one basis, looking for patterns that we could then recommend. We are also noticing that the project size, if you look under size there, not all of them are insignificant. So there's some fairly sizable efforts that were underway. They were not all just new development. Some of them were medical devices. Another one was a legacy replacement effort. So there's an interesting range of domains as well. So we contacted these organizations to analyze further how they were achieving these results. Next slide. What we found is that each was using a similar model. They were looking at recognizing defects because they knew that they were being injected continuously across the life cycle. So they were specifically implementing defect removal steps at each point along the process. What we found to be extremely interesting, though, is that they were also focused on removing them as early as possible. If you look at that early defect removal across the life cycle diagram, they would identify and remove them as quickly as they could because they found that this was the most cost-effective way of doing business. So they were, by implementing this process, they were also gaining a lower cost for total cost of development because they were not dealing with the reactive process later on in the cycle. Next slide. We have some funding relationships that we felt were useful to understand at this point, because what we were seeing was that good quality could actually be implemented with good safety and security results at lower costs. Next slide. These successful projects, as they were working through their life cycle steps, each were focused on quality with the defect removals, but they were gaining the safety and security results because they were also applying safety and security defect removals at the same time. At each step in the life cycle, they would focus on quality, and then they would also focus on safety or security to remove as many of those defects as early as possible. So you'll see a design review and then an inspection, and those inspections were their safety resources or their knowledgeable security experts. And same at the code, and then these two groups were working in tandem under verification and validation. So the result would be low defects, low vulnerabilities, at release time. Next slide. What they were also doing during each step of the process was collecting a huge range of metrics. Some of these were automated in terms of the processes they were performing. Many others were personally reported by each participant in the process who were very carefully tracking their results and assembling that information so that they could identify not only how well the process was performing and where they were finding defects and removing, as you saw in that chart a couple of slides back. What they were also doing was identifying patterns of repeated errors that they would focus on as potential training opportunities, recognizing that if they could educate their resources so that they would not repeatedly create the same errors, this too would create more defect removal opportunities as well as reduce cost. So the focus was on prevention as well as detection, and as early in the life cycle as possible. Next step. What they also found and were able to successfully document was that they got higher quality, they got better safety and security results, they also got improved reliability. So the integration was a very powerful message that we were seeing. Next slide. We further researched how these quality techniques that we were seeing in these 5 projects could help organizations specifically focus on security vulnerabilities. We went back to the common weakness enumeration and specifically looked at the top 25 that have been identified for several years as the toughest problems, and analyze them jointly as security experts and safety and quality experts, looking at them to say, how can we effectively address these more readily during the life cycle, and how much will quality help us? What we found when we were looking at just code checking was that if we had implemented peer review and very close quality checking techniques as these 5 projects, then we would expect to have 11 out of the top 25 SANS most egregious problems addressed. Those would be defects, vulnerabilities that would be not issues for the resulting software. When we looked further into how the design reviews might help us, this one was a little bit more interesting because it's not a direct translation of quality into safety or security results, because what the design reviews would be looking for would be missing or improper requirements. In the case of using quality, if the requirements were well articulated and well structured to begin with, and if those requirements were effectively translated into the design and the code that the developers were looking at, then we could expect 12 out of these top 25 to be addressed. So that starts to put a major dent in the safety and security challenges that we would be looking at implementation if we were implementing good quality, assuming that we had good security requirements specified. Next slide. What you can assume is if you have poor quality, that is a good predictor of poor security, because out of your defects, you're going to be seeing at least 1 to 5% of them as vulnerabilities. And neither quality nor safety or security is going to improve by accident. And you can't just go in at the end and run some tests and expect to get this kind of results. What you have to begin to look at is a full life cycle approach for effectively identifying and removing these defects and vulnerabilities throughout the life cycle to really capitalize on what we have seen these 5 projects to be successful at. But what you gain is the right behaviors, and you gain the right structures so that it becomes a repeatable mechanism that can produce high quality, high security results at a lower cost. Next slide. I want to leave you with this picture in your mind that of the world of defects, a segment of them will be found within your quality analysis, but recognize that there's another portion that will not. So we are not saying that this is a replacement for static analysis tools or any other effective security results. What it can be, though, is a very powerful strengthening of them based on improving the quality of the software and identifying at least the portion, which could be up to half of the most difficult security problems, just through implementing effective quality activities within the life cycle. Next slide. There are some real challenges that we've seen based on just the metrics and the data that is or isn't being collected within your standard life cycle. So not only are you looking at implementing defect removal steps throughout the life cycle, but we also need to look at improving the kinds of metrics that are being collected. If we wanted to look at an existing product in like open source or the National Vulnerability Database and estimate how good their quality is and what percentage these vulnerabilities are being reported, that would be very difficult because we don't have that data linked to specific product releases. So the relationship of how the product is being built versus the data that we're accumulating doesn't allow us to use this 1 to 5% rule of thumb. But as you're going through your own life cycle or your own acquisition for a specific product development, you can apply this to gain an understanding of where you are and kind of build some expectations so that if you're running static analysis tools, you're tracking a lot of defects, then a lot of vulnerabilities rather, then you can use that as a 1 to 5% of kind of the overall defects and look at that relationship. And if you have mechanisms in place that are tracking defects throughout using good quality, then you can use the rule of thumb of 1 to 5% of those are probably vulnerabilities to get some sense of the risk that you are absorbing if you were to implement at that point in time. So I would urge you to consider implementing higher quality techniques throughout the life cycle and to improve the metrics being collected in general throughout the life cycle so that these become a stronger base to build on so that we can better understand what we are dealing with and improve what we are implementing in terms of software and security. Next slide. I've provided my contact information here. I'd be very interested if you have data that would either support or refute our results. We certainly recognize we're working with a small sample set here, and we're making some assumptions based on what we've seen. But we feel like that it's a strong recommendation and something that is worth looking at and considering further. Thank you for your attention, and I'd be happy to address any questions.
Carol, thank you very much. I want to mention that the Consortium for IT Software Quality, one of our charters is to establish measures of software qualities that you can obtain from analyzing the source code. And the Object Management Group has just approved as a standard one of those measures, which is based on the top 25 common weakness enumerations that Carol mentioned earlier as a security measure, a measure that can be taken on the code itself, looking for security vulnerabilities and providing a measure of of the level of security in the code itself. So this is a critically important topic. We see a lot of CEOs now getting interested because of the cost of the breaches that we're seeing in large corporations. So let's open the floor to questions to Carol. If you have one, Tracy, have you been tracking the questions that have been coming in?
Yeah. Hi, Bill. We do have a few questions here. First, we should mention that we'll be posting Carol's presentation to the CISQ website this afternoon. That's www.it-cisc.org, and we'll also send you an email so you have a link to the presentation. So looking at this, just a couple questions that came in. First question is, how do the numbers change in an agile design and development environment?
Well, I would say the numbers don't really change because one of our projects was using an agile life cycle, and one of them was using a waterfall. So in terms of the tracking opportunities and capabilities, it's more of when you're taking your information and collecting your data, but you're still looking at early defect removal and looking at tracking those defects and monitoring them as you're moving through the life cycle. And as part of that, also integrating safety or security expertise at each one of those steps.
Thank you. Next question. Does a system that crashes in production help or hurt a hacker's chances to penetrate it once it crashes?
Well, it depends on how it crashes, obviously, but by crashing it provides an opportunity because that is unexpected behavior, and it provides an experimental basis for which to do potential damage, to look for ways for elevating privileges or making the software do things that are unexpected and unintended that provide favors to the hacker. And so by eliminating those potentials through the quality improvement, that provides a way to reduce these opportunities for the hackers.
Thank you, Carol. How did the study determine or standardize perceived poor quality across the 5 projects?
We were using the standard definitions, and what we were seeing, the advantage we had of the 5 projects is that they were all using the same quality process, which was the TSP approach. So in some sense, we went in with a standard strategy that was being used to begin with. So we probably had less synchronization challenges than most research would do because it was pulled from this same basis. Mm-hmm. If we were comparing our data to others, we might have a little bit more of an analysis perspective to do there.
And then are there any prediction models for vulnerabilities using metrics?
Well, we basically are looking at TSP is a prediction approach for quality, so that as you're going through and collecting your metrics, you are creating a way to predict the results based on how you're performing. Our assumption is that we can leverage that strategy. I wouldn't use 5 specific data examples as sufficient to state that as a given fact, but it certainly is a strong indicator. And by tracking the defects, by removing them early, and then with this 1 to 5% comparison for vulnerabilities, then you have a way to begin to think about how you're reducing your vulnerabilities as you're moving through the life cycle, which does provide you with at least a rule of thumb prediction capability. I won't say that we are at the point where we would confirm this as a standard, but there are so little measurement mechanisms right now in terms of end results that we feel like this one is positive and is showing the right direction, so that we would urge you to consider using this as a rule of thumb, so to speak.
Mm-hmm.
And certainly if others are collecting data and would share that with us in terms of helping us confirm our results, then we can have a stronger statement about where we can go with this.
Mm-hmm. I think we have time for one more question, and the rest we can address after the webinar as well. We've captured them all and can send you a note. Last question, are there any metrics looking at and comparing the cost per defect or cost per defect fix between security defects and other functional defects?
I have not seen any numbers on that. The numbers that we have are basically generalized from looking at specific defects and the costs for that. I'm not aware that the defects themselves have been triaged into the kind of defect. We have been exploring, especially with some of the open source, the range of defects that are actually reported and how we might gain better metrics. And what we are finding is that the collection of information about defects is really not sufficiently rich for us to do that. Too frequently, they are just reported as fix, as opposed to a security fix versus a safety fix versus a functional activity fix. So we are not seeing sufficient data to make any kind of prediction that way.
Okay. I think we're all set. Bill, did you have any more thoughts, or should we wrap up? I also wanted to mention we've recorded today's webinar, so we'll also send you a link to the presentation on the CISQ YouTube channel this afternoon.
And thank you for everyone for attending, and we'll have some future webinars we'll announce that will have similar topics, and hopefully have information that's just as valuable as the research results that Carol just presented. So thank you for attending.
Great. Have a good day.
Thanks. Bye.
Thanks, Carol.